do a save here, just to get started so we can come back if I mess up again. We'll call this ready, whatever, ready for rims, something like that. This will put an extra row in our data panel here. We've seen that before. So got two bodies correctly sorted here. We're going to try and put rims on here. I am losing my voice a bit, so I'm drinking tea. One of the things that they show here, which is interesting in our sample, which we should try for perhaps, is the foot. Sticks out quite a bit more. Why? Because we want to put a fastener through here and into some substrate, something underneath. There's also a hollow to make the machining more convenient, but fit and finish is easier with the hollow. The thing that we want to be able to do is be able to get fasteners in at the bottom. We also want to get fasteners in at the top, but you notice this is quite a bit thinner. So we're going to try and follow that. That means the fasteners above in the cap are straight through the top. We might have to do some adjusting for that. So off we go. I'm not quite sure how this is going to go. Let's see what happens. After we've done the feet and the rims, we'll put some caps on this. We're only going to deal with fasteners maybe in the third video on probably the rims. Any theory we get from this, we can easily stretch over to the other side. Nonetheless, sorry, I'm just looking at this here. The plan is we're going to do another sketch. I know, it's amazing. Colin is going to do tons of sketches here. So let's put a sketch on another available plane. So we'll just open this up, new sketch. And I'm going to put it on this ZX or XZ. Make sure, I was using that to make sure I got the right one. I'm just going to put two rectangles for now to remind myself where we are. I can slice. Perfect. Now, if we remember right what we did, trying to see what's going on here. Here we go. So when we did our original housing, we had, just double click to pull that out a little higher. Let's move it out of the way. We've got our wall thickness here. Our origin is here. So we actually, if I remember right, we came off the back of the bearing. So let's do the same here. So I'm going to project a projection, which is maybe not completely kosher. This is the back of the bearing. Put that onto the sketch. Hide those other sketches for now. Take a look at our sample. Top of the foot is kind of slightly above the bottom of the inside of the housing. What am I doing? What's going on here? There we go. So if you double click, you can pull the whole thing in one piece. If you don't double click, you just get one. So I want it maybe around there. So let's align things. I'll put this edge on that projected point. Lines it with the inside of the housing, and the logic is coherent. Let's go with, I'm going to project another thing, which is this edge. And although, hold on, no, not one said, let's use a sketch, sorry. That's not the sketch. This second sketch, let's project the sketch itself. That's better. There we go. So now we're using the sketch to control things. Let's say that we want this to be up. That's the inside of the housing core, if you want to think of it that way. Let's put it up half a wall thickness. Fine. Now, looking at our sample, looks like maybe one wall thickness below. So we've got a wall thickness here, so that'll be from this point again. 2 wall thicknesses, so 2 NWT times 2. Perfect. Now, what about fasteners? M8. We're just going to take a small M10. How big are those? Let's have a little quick look at my master card. We'll finish that sketch. We're not going to place anything, we're just going to have a look. Cap screw. Metric. Further down in here is a head diameter filter. So you can kind of see what's going on here. But what if we just wanted to know what an M8 is? So we're going to look at this both ways. So if we picked an M8, just out of interest, we should be able to see that it's now filtered down 13 millimeters. So the only option here is 13. That means M8 gives us a 13 millimeter diameter head and a cap screw. So we need at least 13 if we want an M8. What if we also want to accommodate an M10? Well, it's slightly bigger. 16. So because we're using a cap, we don't need room for a wrench, so it can be quite tight. But we've got 16 here. Sorry, where to go? 16 millimeters. Cancel that. So if we want an M10, we need at least 16. We need a little bit of a gap here as well. This is not a bad thing. But our sketch, where's sketch 1? This one's on that spot. That's the origin. And there's 2 millimeters in here, so a 2 millimeter gap might not be so bad. So what do we say, 16, I think? Oh, be helpful if I was in the sketch. Let's press the wrong stuff a lot. Edit the sketch, come on, man. Dimension 16. Now that would be quite tight at the outside, so let's say 16 plus 2. That would be square set. So that's actually 20 millimeters from the side. It's not bad. Kind of, at least there's some logic to it. So let's go with that. Finish the sketch. Now, before we start getting carried away with the top one, let's make sure this one works. Turn off our analysis. Turn off our analysis. And let's do a sweep. The blue for solid. That's our path. Oh, sorry, that's our profile path. It'll assume a cut, that's fine. It's annoying, sometimes it goes right in front. The little micro guy. Tends to stay-ish where you put it. It's good. There we go. Now, I'm not sure if I like these corners, to be honest. Looking at the preview, thinking, it's a little janky. No, let's do some filleting first. Let's see, have a look here at the body. Temptation is to start going at it with a fillet tool, fillet feature. Well, let's be a little, we can be a little smarter on one side, but we lose having to fillet the inside. So let's keep that, let's do a fillet on the larger part, and then we'll keep in our back pocket a fillet, tidying up fillet at the end. Let's do it right before the shell. Which makes sense in a way. We've got this chamfer going on, and then fillet would make sense. So F for fillet. If we can pick faces, but if we do that, we get the whole goes in the bottom as well. Don't like that. So let's X that row. Keep the fillet tool happy, and then instead just pick edges. It's really only 2, 3, 4 altogether. NWT would be good, divided by, say, 2. That'll give us 2.5. See how that looks? Run it all the way to out to the end of the part. It's not bad, I suppose. It's kind of good. Notice these are not 2.5 because of the shell. Radius 7.5. Fun. Let's try our sweep again. Profile. Path should work now because we have chain select. Get a nicer outside and not a cut but a join. We'll lose the chamfer on the inside because of the way the rectangle is constructed. It's okay. It's not too bad. Let's edit the sketch to add another rim at the top. We can just use a slice here. Now, if we remember right, we needed 16 altogether for an M10. I don't think we should use that higher up here because we're just trying to hold the top down. So we could, for example, let's see what they've got here. It's flush on the top, sticks out a little bit. So let's see here. Do we have anything we can use? Well, let's just project this top edge. Put that. Oh, hold on. I can't do that. Sorry. Just realized I want to do something different here. I'd like to put this further back. I'd like to keep the sketches all together. I'm doing a bad thing there. So the sketch is already in spot. Let's do this properly. So this is our outside wall, we can tell from our gears. So it's aligned on the inside. This is our wall eventually. So let's make sure we're getting this right here. This is my outside of the edge. Sorry, thinking. I think that's in the wrong spot. Hold on, we might have to fix that. Yeah, it's too over. That's not quite right. Gonna put a line across. Sorry, I forgot about the small offset because the bearing was slightly off. So that's our projected point. Let's put another point here on the line to mention it. Well, we could say 0.2, but really it should be. I'm getting confused here. Let's make it close. So it's going to be right. So it's going to be 12. Right on top of each other. So let's see, we can't really hide things, so I'm going to dimension from this. This will make almost zero difference to this. I'm just trying to be picky and correct here. A casting 0.02. So what I'm trying to do is figure out where I am here. So I've got 2 plus NWT from that side. So let's edit our sketch. So I want to dimension from an easy line to this guy. NWT plus 2, I think, should work. unless I'm losing my mind. Let's make sure we can now change stuff. No, that's not right. So I'm okay with this. Show dimensions. I want it to be aligned with the edge. So it was just NWT. So you can kind of get around the history by showing the dimensions. Everything looks better now. Pulling it kind of more into shape. We see a problem. We're quite close here. We've got too much going on in here. And we're going to have, again, undercut issues, all the rest. We are going to break our own rule here. There's no web or rib shown here at all. And nor is there shown inside of this part. It might be able to do a double part casting on the outside. I'm going to try and pretend that we just don't know about it. So the problem is, though, that we've got, it's too close, this, so I'm going to move it up. The problem is I'm going to have to decrease this, which means I have to increase the height. So let's do that. So leave everything as is, show all the sketches, show all the dimensions. Don't need the layout top, but the layout right is important. So, oh, yeah, I'm just going from one to the other. Let's get rid of these gear shafts. Excuse me. I'd like to move this up a bit. So to be honest, it's probably going to be, I'd like it to be somewhere here. So let's try 65. That's not bad, but now it's right through this part. So let's adjust this. We'll say D1 plus 20. Starts to get taller, which is, you know, it's okay. But maybe a little bit too tall. It's not bad. Oh. A little better. Interestingly, I wonder how long this is, so let's measure that. $10 millimeters in the Z. That's fine. Maybe we can use that to our advantage. So I want to put that in the middle. So let's have a line that comes from the middle of this guy, horizontal. Can make it construction. Project this cut line from the other sketch, lock them together. Now our dimension could be easily 10 on each side. And we needed 16 or 18-ish for an M10. Let's go for an M5. So maybe let's guess here at, say, 10 for now. Finish the sketch. Let's have a little, we're going to actually do a check this time with a couple of fasteners. So let's just continue on with our sweep. So our splits here in front. Oh, don't want the split in front of, I don't want the sweep in front of the split. Sorry, don't want the split before the sweep. Gonna have to delete that sweep. Okay, delete the sweep. Sorry about that. And do the sweeps again before the split. There we go. So Sweep. One more time with the sweep. Path. Because we've done our fillets and all the rest, it gives us a full thing as a join. Do it again. Path. Now what do we pick? Well, maybe we can choose this. That looks fine. So using kind of a path, similar but just one step up, caused by the old sweep. We won't be able to rearrange these sweeps now. That's fine. And then our last event is the split. So this is not going to work, is it? Right, if we have this top here, we have all this stuff going on up here. It's not so great. So we can't actually do this unless we make it bigger. So let's see here. Maybe we need to make it bigger and go right through. One of the things that's a guide for us is, maybe we should just bolt right through the rim so we can make it quite a bit longer and narrower. So we could do this NWT times 2, which is only 10. Make this come out further. So maybe we can fit some fasteners in here. How do we know? Well, let's say we need M10s underneath and we want to use an M8 above. Let's actually place an M8. So, cap screw from McMaster. We're not going to use this in the end, but we will use it as a sizer. I want an M8 here. So metric, cap screw, M8. And where we wanted to go through and then put a fastener on the other side. So maybe we have a cap screw and a washer, a lock washer of some sort. So we just need the head diameter 13. We are going to go with the smallest one. Let's go for 16. We're not going to use this. It doesn't really matter. Download. There it is. Move it into place, kind of, just to get a feel for what's going on. It's upside down. Move it up to the right spot-ish. Make sure it's the right way. So we need about 2 millimeters, say, around it. So if we want to use an M8, we would have to move it another, so from 4.5 to 6.5. So that's quite far out. It is what it is. So let's adjust our measurements here. Right now we're at 15, we're getting longer and longer. 18, 20, starting to hesitate. 22, everyone's still working. Yep. So there's our part there. Let's place another M10. Let's place an M10. See if we get the right size. Length is not important for this guy. Let's just go with. We're down here. We've got a 10, so let's go 15 beyond that. Maybe get 5 threads. This is a 1.5, so we want 5 threads, probably 18, 19, 20. Course is probably fine. Let's go for 1.5. and fully threaded. The length is 15. That's good. Let's try that. Again, we're not really that bothered. We just want to get a size here. So about the same spot. It's way too short. Anyway. Use the front, move it around a bit. That's my 2mm line there anyway, so that's actually not too bad size-wise. So size-wise, that's okay. So we can use an M8 and an M10. We're going to use the fastener feature to place these, so we're not getting too worried about exactly what's going on here. We're just using them for sizing. So that's our rims done. We'll leave that there like that for now. We'll delete those fasteners later. Last thing we're going to do in this video is a couple of caps. So we can basically just use a simple cap, and we're going to reuse our sketch here. So let's hide our two placed, adjust our sketch a little bit to make a cap. Very simple cap, just to make a point about how it might be made up. I'm not going to detail it, so we just need a line here. We can do another slot shape, or we can just do what we did before and snap things. We can see that double tangency. So we'll use that in concert with these other things. So that's our new sketch. Let's make a cap here. Now we're right on this one, so let's use this one as a prototype. So we'll make a new body here, so we'll do an extrude. And let's show our parts. I know that I'm covering this up, so we'll deal with that later. So let's just give it a nice gap. I'd like to get beyond these rings as well. So maybe 8. And new body. Now let's do another extrude. We've got a lot of extrudes going on here, so there's a lot of busy work here. Same again, but with the inner cores. But we need a hole here, so let's continue doing it on the other side. So we'll go from pro object offset, say minus, that's not minus, -8. No, the object is 0. Sorry, we're going -8. New body. Is that long enough? Yep. So, okay. We're going to make a point here about this one, so we'll do the back first. Do the sketch one more time with the innards. See if we can get that. Hold on here. Hide our parts. Hide all our bodies. Get the whole thing, so the insides as well. Show our bodies again. Now I want to go from an object, the end of this cap, and go another, say, NWT, and we're going to join here. And it's not going the right way, it's minus NWT. Make sure we're getting that right, show apart. Yep. So that's okay. Because it's another body. It completely covers, hides the shafts. That's what we want. The bearings are protected. On this side, we need some extra stuff here. We are going to have the shafts showing. We want to have, of course, the shafts have to protrude through the hole, or sorry, shafts have to protrude through the cover. Now we've hidden, how far have we gotten out here? It's a question, do we want to go to these or to this? Let's try, actually I'm going to draw a circle here. Same here, we've got a center to pick from. Getting a little busy in here, but let's turn off our analysis. Let's turn off our analysis. Hide our parts. These are the two that we just drew. They don't necessarily have to be the same size. So let's just try and pick one at a time here. Good Lord. Try and ignore this ring in the back. It's not the outside surfaces are not centered. So let's just see where we go. I'm looking at diameter down here. So 28's not bad. Dimension that to 28. See how we go with that. Same over here. If we can find it. Where did it go? Hide it. Escape out of the dimension tool. Oh, which of course puts it back. There we go. So like, I wonder if we can get right in here. So let's see, that's maybe interesting. 28 again. How does that work out? So 2 28s. Doesn't change anything except for when we do our next extrude. Oh, no. Let's do that again. There's tons of stuff going on here. This is where it all starts getting really fun and frolic filled. This is our sketch rafter. We don't need that. We don't need this unnamed sketch right now. What I want to do is an extrude with this. No. With the sketch and all the bits and the loop. There we go. Right now I clicked that rim by accident, so I'm going to start from an object. Oh, good Lord. Start from an object and continue a distance out. NWT again. Join. Have a look at our analysis. Looks fine. Let's see how we did. Got a good gap there. 28's looking good. And you need to use the other analysis to see this one. Oh no. Collision here. So let's make this one a little bigger. 30. That's not quite right. 32. There we go. So what is this diameter that we're avoiding here? 25. So we're a little closer. We could be a little closer if we wanted 1. 27 and 32. Tidies it up. Let's go with that. This makes our cover non-symmetrical, but if we did flip the shafts, we could actually just flip the cover upside down. So there we go. While I'm here, let's rename this guy. Layout. Right. No. That's front. That's right. Oh, come on now. Didn't want that. Trying to figure out which one's which here. That's the front. That's the right. That's the top. There we go. Okay, so all our parts are kind of in. Before I finish this video, I'm just going to tidy this up a little bit here with some chamfers. So let's hide everything but those bodies. Oh, that's body 1 and 2. Get rid of these guys. Turn off our analysis. Get rid of our sketches for a second. And let's just tidy this up. We're not going to put fasteners in this, but it would normally go in here. First chamfer. I'm going to make this unequal. And turn on analysis so I can see what I'm doing. So let's go with 2 distances. Actually, distance and angle. Notice what see what it's doing. Let's go for 2 and 30. So it's going around this middle part. Let's make it 5. 510, no, 10. That looks quite good. Let's see if we get the same on the other side. There we go. That's nice. We have kind of screwed up in here though, so let's add another one and put a little chamfer on the inside of this. These 2 faces. Call that 2, say. Make sure we're doing okay. And these have to go on to the shafts. It's probably not a big deal if these are sharp, so let's just say okay to that. Make sure everything's still not touching. Now, last but not least, we have to deal with this. This is a problem because we have to avoid the ring on this. Now, SKF might phone us up after this and say you can't do this. It's fine. So this problem that we're looking at here, the other one is on the other side is fine because this is just a cover that's not really stressed in any way. The problem with this side is that we're not supporting the back of this bearing properly now. So we're going to finish this guy by fixing up this problem. We're going to do it in a strange way. I want to do it in between that chamfer, fix up, and we're going to block in some stuff and sort this out. So let's hide the shafts and show our sketch. No, show the sketch. So just adding more and more onto this. The problem we have is the ring is in the way. So let's show one of these. We'll project. Well, we don't really need to. What I need is a nice rational number here. So let's draw yet another circle. Oh, let's edit the sketch. Circle. Going to go out slightly beyond this ring. We could go as high as 70. Same probably on the other side. Let's just make sure though. So another circle. Yeah, 70 is fine. So that's the gap we need around. So that's fine. The thing is though, we do need to adjust our cover here. So let's do that as well. So this extrusion is the question. Fix the extrusion. So I'm actually going to add material to that. Oh, not that. Be helpful if I was editing the feature. Get the right one. It's this one. Sorry, it's asking me which one. I'm not looking at my own screen here. Add that. So we're actually making this cover quite a bit more complex. That's okay. It's fine. Then all we need to do is actually extrude out one more time. Be helpful if I did that right though. Hold on. Missed a piece. That's better. Let's do a little check here. Show some stuff. We're now up and against the bearing in both spots. Perfect. That's good. Let's check our chamfer's still working. It's not happy, but maybe it's okay. There we go. Just fixed itself. Just it's saying the edges moved. Do you really want this? So this is looking okay. Let's go back one step and fix it one more time. So I'm going to do an extrude here. Let's get rid of these shafts. Well, let's find out, first, how wide this is. Maybe we can figure something out here. There's a sketch we can use. Let's find out how wide that line is. 1.7. I'm going to extrude out based on this. 2. We'll go past it for sure. So let's do that. Hide our parts. One more extrusion. So this is our ring. And we're going to go into our cap. Now there's that 0.02 going around on it, going around in there, so we should be okay. So let's see okay with that. Check our parts. Turn on all of our bodies. Hide the sketches if they're getting in the way. That does look fine. One more step out. Chamfers are fine. Or are they? This goes on. We are missing something. Oh no. Well, we do have to do what we're told, so this is what's going on here. We're getting into the point where our sketch is getting too complicated. So trying to think the best way to do this here. Okay, so I've got an idea. I suppose I'm gonna split a face here, actually. Pre-select them. If I can do both at once. Go for split face. 2 are selected. Nice. Splitting tool, the front of this bearing. Extend. Does the whole thing. Let's see if we can make this smaller with the old press pull. Where's there? There it is. Notice it's it's janking around on the chamfer as well. Let's put that before the chamfer and then do this before the chamfer. Do it again. Press pull. I wonder if we can do them both at once. Oh. Got the wrong thing there. Let's try again. Oh, look at that. Nice. Let's go for rational number. Let's have a look. It's almost at the opening of the bearing, so there's quite a bit of depth. Allowed there. What happened? Stopped working. Let's pick it again. Don't jump between apps, obviously. It did work. I saw it. Come on, man. Cancel that. Sometimes the command gets a bit stuck. Press pull. If I move inside of the apps or between apps. I'm gonna go in 2.5. Include our chamfer. That's some crazy work right there. There we go. So there's our caps done. We're not, next would be figuring out how to put fasteners through here, little lands, a pattern of fasteners, some extra fun through the middle of this guy and all the rest. But for us, let's not do that in this video. We're going to go ahead here and do a pattern on a line instead up here on the two rims that we've added. That's on the next video. Sorry about all that. Thanks for watching. See you in the next one where we're going to be finishing her off. Thanks for watching.